Good afternoon, everyone. I'm Kevin Galetz, and I'm an Industry Education Council coordinator working with the Regina District Industry Education Council, excuse me, and Sunwest School Division. Today it's my pleasure to introduce Travis Poprosky, a former student of mine and graduate of Rosetown Central High School. Travis is an irrigation technologist, and he works for Sask Agriculture. Today, Travis will tell us more about what this occupation is all about and the journey he took to get to this point. And just a reminder before we begin, this session is being recorded and will appear on the RDIEC YouTube channel for anyone to view in the future. So if any students do see this, please go to the website, the RDIEC website at www.rdiec.ca and complete a student survey. You can find that survey at the top of the homepage. And survey gets your name in for a monthly draw. It certainly helps us out with how we can make improvements and whatnot in the future. Again, www.rdiec.ca. And I'll turn it over to Travis. Welcome.
Hey everyone, thanks Kevin for the introduction and for the ability to provide this career spotlight presentation. As Kevin said, my name is Travis Poprosky and I'm an irrigation technologist for the Ministry of Agriculture based out of Outlook, Saskatchewan. An irrigation technologist with the Ministry of Agriculture is responsible to provide surveying and drafting technical support for the province's irrigation sector. This includes assisting with the planning, design, construction, and inspection of new or rehabilitated irrigation projects. I've broken the job tasks into a percentage of time spent on each. 75% of the job includes identifying, collecting, presenting, and recording relevant information through observation, surveying, drafting, sampling, or inspecting. Examples include, but are not limited to, construction drainage surveys, staking pivot points, laying out main lines, cross-section surveys, construction inspections, field inspections for potential irrigation projects, and drafting plans for irrigation and drainage. 20% of the job is the ability to collect and analyze relevant data, develop, implement, monitor, and recommend project plans to resolve operational issues and improve work processes and systems. We use the data to provide recommendations to the clients and stakeholders. 5% of the job would be to accurately compile data and monitor quality control and test results for statistical information purposes. This is to provide accurate information to irrigated stakeholders and other government agencies. Some of the job traits and skills that would be ideal to have are attention to detail, good communication skills, self-motivated, take initiative to deliver high quality work in a timely manner, and be good with numbers, as this position heavily involves math. Field work is a big part of this job, so there's lots of travel to and from different job sites around the province. This picture was taken right by Lake Diefenbaker, where the majority of the work takes place, but this job can take you all over the province. An example would be this map showing the furthest of my projects I've been involved with. The Southwest project was 6 miles away from the US and Alberta border. The East project was very close to the Manitoba border, and the Northern project was located just before solid bush began. This shows the extent of the projects and everything in between. You can see the Outlook office pin in the middle. That would be kind of the focus of where lots of the work takes place. When I'm not in the field, this is a picture of my office setup. The office is located in Outlook, Saskatchewan, and has 22 employees. With COVID, many have been working from home to allow for the distancing guidelines. Over the next few slides, I'll focus on what I would say the 3 main types of work I do are, the 75%. 1 being RTK surveying, 2 is construction monitoring or inspecting, and 3rd is drafting and design. A simple explanation of RTK surveying is a base station is set up over a benchmark and receives signals from the satellites, corrects the information, and shares the corrections with the rover to provide accurate locations based on the specified coordinate system. The picture on the right shows my base station set up over a known point that's a pin right beside the pink flagging. And then off the back of the truck is the movable rover with 2 centimeter accuracy. And the data collector that's right by the yellow container, kind of halfway down, stores all the data. The top right picture is an animation of how we find the survey pins that are the legal boundaries of a parcel. We use a pin finder to locate the pins underground. On the left, there's a picture showing how deep some of the old pins could be if they happen to be under a blow ridge or along a fence line. The area in orange is what's shown on some of the old pins. It shows the land location details on the pin. This one was planted in 1915, so it's over 100 years old. And the bottom right is me doing a topography survey in the winter with the GPS on the rack of the quad. So the base station would be set up out of sight, and that's the rover on top of the quad. These are some pictures of the construction side of the job. On the left, it shows our stakes where the pipe will be going when it's drilled under the highway. The middle picture shows a common trench for 2 pipes, and then they branch to either pivot point on their own. On the right, it shows a couple miles of pipe that have been dug into the ground. Pipe is required to be at least 3 feet deep, and some RMs require up to 6 feet deep for pipe burial. This is an example of a product delivered to the client, highways, and rail line company. This specific example crosses a double-lane highway and rail line with a directional bore. It was drafted using AutoCAD Civil 3D and designed using the survey data gathered. Here's a quick drainage design for a client. The topography map was created off the data collected when I flew the field with the drone. For this parcel specifically, it took about 1,100 pictures, and they were all stitched together to create a usable elevation data map. And on the top, it shows a profile that was created based on the natural ground and the proposed pipeline. The design process utilizes the survey data, multiple Excel spreadsheets, and an irrigation design software to calculate what is needed to run an irrigation project. The design includes the irrigation system specifications, including the water flow and the pressures, the pipeline pressures and pipe diameters, and the pump horsepower and total dynamic head requirements. The total dynamic head requirements are a calculation of the total friction loss and elevation losses through the pipeline and the pivot. These are some drone shots I took of an irrigation canal connecting Lake Diefenbaker to the Broderick Reservoir. Lake Diefenbaker has the capacity to service up to 700,000 irrigated acres, in addition to the acres currently irrigated. This canal has the capacity to service around 65,000 acres. The amount of water moving at the time of the pictures was 17.5 meters cubed per second, with a design capacity of 28 meters cubed per second, which is around 84,000 cans of pop per second. And a pivot will use around 168 cans of pop per second, to put it into a little bit of perspective. This is a quick drone video that I took of a completed project. The pivot is irrigating a canola field. To irrigate a quarter section with about a half an inch of water takes approximately 36 hours to spin all the way around, and will use approximately 7 million liters of water, which would drain 3 Olympic-sized swimming pools in 36 hours. The rewards of the occupation are an excellent work-life balance, lots of opportunities for additional training. The ability to work on a project from initiation to completion is my favorite reward, and the ability to provide assistance to some really great farmers. Every job has some challenges, and some of the main ones for this job are the limited opportunity for career advancement in specifically trained roles. There's just not that many jobs out there yet. Salary is maxed out after 5 years. The competition for open positions is often based on seniority and not directly training or skill set. And sometimes there are hard conversations to be had with farmers who are not eligible to develop irrigation. Some examples could be salty soil, bad water quality, or even no water available. A pivot uses a lot of water. The salary and benefits, the salary range starts at $27 per hour and goes to $34 per hour for an entry-level irrigation technologist. And then for the senior irrigation technologist, it starts at $37 per hour and goes to $50 per hour. The government of Saskatchewan has excellent health and dental benefits, and the pension is a very good employer matched pension. The typical work week is 37.33 hours per week, which is broken down to every third Friday off. Some overtime is required in the spring and fall busy seasons. Yeah, this job has an excellent work-life balance. Office hours are 8 to 5, Monday to Friday, with weekends off. Some overtime is required, but it is compensated. Like I said in the previous slide, every third Friday off. And then the busy seasons are the spring and fall, with the winter being mostly office work. So the education requirements for this position would be a diploma in an engineering technology program. The post-secondary options for training, I took the geomatics and surveying engineering technology program at Sask. The other accepted programs would be the civil engineering technologies or the water resource technologies or anything similar to those. I am a registered professional applied science technologist with the Technology Professionals of Saskatchewan, which was formerly Sask. They provide the professional seals for Saskatchewan. And extra training I've taken since working with the ministry are project planning and project management certificate courses through Sask Polytech. Yeah, so my journey, during my grade 12 year in Rosestown, I had applied and been accepted into the engineering design and draft technology program at Sask Polytech that was set to begin in the fall of 2013. The summer after I graduated, I worked for a local farmer and moved to Moose Jaw in September. After the second semester at Sask Polytech, it's changed now, but at the time you did 2 semesters and then you did an 8-month work term. So during the work term, I worked with Meridian Surveys out of Saskatoon as a draftsman. And the geomatics program and the drafting program are very similar, even have lots of the same classes, and they're really connected. Some of the main classes are even combined. And I really enjoyed the surveying courses, so I began the process to switch from the drafting program into the geomatics program to go into a more of a field position role. The switch was fairly easy, but I did have to complete a couple, I had to challenge a couple course final exams to complete the transfer without adding any additional time. I completed the geomatics program and graduated in December of 2015. In January of 2016, I began working for Meridian Surveys as a survey assistant for a twinned pipeline project that was taking place just north of Edmonton, Alberta. It was a 36-inch line twinned with a 20-inch line, so some really big pipe. I really enjoyed the work and learned a lot, but being on the road all the time just wasn't for me. After the project was completed, I had the opportunity to apply and start with the Ministry of Agriculture as an irrigation technologist in Outlook in October. So opportunities available. The job market is fairly good for engineering technologists. There's not a lot of irrigation technologist positions available at this time, but with irrigation expansion, there could potentially lead to lots of positions opening up. This position could lead into a project management role, a construction management role, or a irrigation supervisor position. Some related occupations that would be similar in pay would be a geomatics technologist, a survey crew chief, a GIS technologist, or a drafting technologist. So in conclusion, I really enjoy my job because each day can be different. I enjoy the opportunity to get outside and see a lot of this province and deal with some really great clients. If you have good math skills and enjoy being outdoors, I would strongly suggest looking into the geomatics program for your future career. Thanks for watching. Any questions?
Yeah, I was writing down quite a few questions, Travis,
No.
because I'm intrigued by what you did here. Just a couple things about from some of the pictures I saw there. Is that your own truck and quad, or is that a supplied vehicle?
Yeah, so the quad is supplied and the truck is a rental. But it's company owned. Yeah.
Company owned, so it's not, you don't have to use your own equipment. So I was wondering, because it didn't look like it was Sask government equipment, so I was just wondering, but it is, in a sense, it is. And you already talked about other jobs with your training a little bit here, but you mentioned, did you say 700,000 more acres could be irrigated out of Lake Diefenbaker in that area? So
Yeah, sorry, go ahead.
how many are there then? Did you know how many currently there are?
I think it's right around 120,000 right now.
Oh,
That
so
would be irrigated just out of Lake Diefenbaker.
expansion is substantial, like, you know, 6 to
Yeah.
7 times more. Oh, okay, yeah. And the
Yeah,
drone, I mean, you showed me your drone one time in your own backyard back home here. I'm just intrigued by that stuff. So can you explain a little bit about the drone and your drone and how you use it and how you learned how to use it, that kind of stuff?
Yeah, so I use a Phantom 4. It's a pretty basic DJI drone. The app that I use is called Drone Deploy, and you pretty much draw a square over top of some Google Earth imagery, set your parameters of how many pictures it needs to take, and then it does the rest. You take off and it flies. It'll come back to you. If your battery's gonna die, it'll land. You change the battery, you tell it to fly again, and it goes and picks up where it left off. So in order to get the accuracy, we actually set out around 8 ground control points per half section, I guess. So kind of 4 ground control points per quarter that are RTK points, and then it all gets corrected. So then you have quite accurate data.
So did you learn all that at college, or did you learn that kind of on the fly through the job?
Yeah, kind of on the fly. Like when I went to Sask, they weren't really a big thing. I believe they do touch on it now a bit more, but drones were really kind of just toys at the time when I went to Sask.
How you use it as part of work.
Yeah.
Did you say up to 2 centimeters accuracy with those, is it the GPS system or whatever?
Yeah.
And
Yeah, so it's probably even better than that, but yeah, that's what they say. It's about 2 centimeters.
So once you find the old pin, and I was impressed the shape that pin was in for 1915, by the way. that was,
Yeah, no.
I thought, wow, I thought something 1915, you'd hardly be able to read that, but that was pretty clear. So if you find a pin and then how far away, you know, you could go a kilometer away and it would measure up to 2 centimeters of accuracy?
Yeah, like typically this stuff, we try not to go over 10 kilometers away from the base, but it can, like I've been close to 20 and it still provides accurate corrections.
That's amazing.
Yeah.
I think it could be that accurate, yeah. And you said at Outlook, where's the office on Outlook? Is it the experimental farm? Is that part of it?
No, that's the federal government that has that. We're right up the 4-way stop, the brick building. It's the same as the town office is located in the one portion of it, and Ministry of Environment and Ministry of Agriculture in the other portion.
That was part of the farm or not. Okay. Are there any other, that was really good. Are there any more questions, Renette or Gord?
I just want to thank you, Travis, because the work that you do is going to make a big difference for future generations as far as not only food production, but just looking after the resource of water, because you know it's a limited resource and it's extremely valuable. So the work that you do is really, really important and pretty cool to be outside with the technology. If kids want to get involved in your industry, are there other jobs that maybe are more readily available that you could direct them to, that you know there's demand right now?
Like within the irrigation industry or within the engineering industry?
The
Irrigation
industry.
Yeah, so there are, it's not a real big job market yet. I mean, there hopefully will be more jobs as expansion takes over, but unless they were looking at kind of working for a farmer and managing specific irrigation equipment, or get into the heavy equipment side of things that does the uptake on irrigation infrastructure. There's lots of surveying jobs for survey specific, I guess, if you want to be on the, like, use survey equipment to collect soil samples, and just certify soils for irrigation. So there'd be something like that, whether working for different crop technology companies, I guess, that would be involved. Our office does that as well. We have 2 irrigation technologists that focus directly on the soil side. So they take the side-by-side and GPS and go up and down the field and take soil samples at kind of trouble spots throughout a field and build maps for irrigation. So there'd be positions like that potentially available. And I think it's just going to get more popular. Like with right now, Lake Diefenbaker actually evaporates more water than is used for irrigation. So we're hoping to change that.
Yeah, and that's what I've heard from some people that are in that a bit, that they say that, you know, we're not tapping into that resource, we're just losing that water to the air.
Yeah.
So
I have a question, Travis. When you left high school, did you know that this was the type of job you wanted? I know sometimes we fall into things just because the doors open up for possibility, but was this one of your jobs that you really wanted to get into? I know that geomatics courses can be quite tough, but is this what you saw yourself doing?
No, not at all. I actually didn't even know what irrigation was. Like, I grew up in Rosetown. You had troubles with water in sloughs versus wanting to put it on your field. So no, I did not. I actually didn't even plan to go into the geomatics program. I was in the engineering design program and actually have my first year of that done, and then switched over into geomatics after I'd seen the surveying side of it. So yeah, I guess I kind of got lucky to find this, and I really enjoy it.
Awesome. Thank you so much for sharing that. I think you've done a very good presentation here, Travis, and I don't think we have any more questions out of this office anyway.
I'm good from this end too, Travis, so I think we'll end it there.
Awesome. Thank you.
Yeah, okay, they recorded